In this video, my dog Jack and I are going to review the practice final exam for grade 6, period 3. I apologize if you hear Jack in the background. Sometimes he shakes and you hear his collar, but here we go. Okay, this first part of the practice test I already reviewed in class, so if you want to fast forward or turn the speed up higher, that's of course recommended. I encourage you during the video viewing that you watch the video actively, meaning you pause the video several times. When you get to a problem, you try it ahead of time and then proceed to hit the play button to see how I solved it. Okay, moving on. The constant of proportionality, recall, is the k value. All right, so you'll see this perhaps on the exam as k. K is featured in this formula, y equals k times x, or you'll see it as k equals y over x. And if you think about it, it's easy to get from one formula to the other. If you take formula 1 and divide it by x on both sides, you would get formula 2. Okay, meaning, if I take this, we start out as y equals kx, and then I come along and divide by x, which is perfectly legal. These x's cancel out, and you get this formula. So you really only need to remember the first formula as opposed to both. Second one, proportional. The word proportional means that two fractions or two ratios are the same, excuse me, even though the numbers are not exactly equivalent. So this would be a proportional relationship between these two ratios. This has the same value of that, therefore that equal sign is valid. Now here, with these numbers, it is obvious that these ratios are equal. But what if you get something like this? How would you handle that? Well, the easiest way to handle these types of problems is to cross multiply. So in this case, if this equal sign is valid, if these numbers are indeed proportional, then cross multiplication must hold. It must be true. So let's cross multiply this and see if we are right. So we would have 8 times 13 equals, but I'm going to put a question mark because the way this problem is worded, we're not sure at this point. And then we're going to multiply 9 times 12. And if they are equal, these two multiplication problems, then this is a proportional relationship. So let me show you how I multiply this out without a calculator. This is how I like to do it. I like to go this way. So I multiply 8 times 10. I forget about the 3 at first. And I put 80 in my mind. Then I forget about the 10 and I multiply 8 times 3. And I put 24 in my mind. And then I'm able to add those up in my head and get 104. Okay, then I would write down 104. I would not try to remember that. Okay, let's do the same thing with the 9 times 12. Okay, I'm going to do that over here in a different color. So over here, I would do 9 times 12 like this. I would say 9 times 10 is 90. And then 9 times 2 is 18. And indeed, they are not the same. So because 104 is not the same as 108, these are not proportional. Okay, let's move on to the next one. Again, I apologize, that should be constraint. And if you think about the word constraint, if you look that word up in the dictionary, it means the same, almost restraint. In other words, someone who is placed in a harness, or if a dog has a leash, that's considered a restraint. A constraint is when there's a restriction. So if you're restraining a dog, that dog is restricted from moving freely. A constraint in math is when you have something like this, 5 over x. The constraint in this particular example would be that x cannot equal 0. And that's because, as you know, we cannot divide by 0. We are not allowed to do that. Numerical expression. The fact that the word expression is listed and not equation, let me write that over here. An equation. Equation has the root equal in it. So an equation has to have an equal sign. That's an example of an equation. Equation also has a left side, as you look at the screen, and a right side. An expression, on the other hand, you don't see the word equal in here. Therefore, an expression is something without an equal sign. And if there are just numbers and no variables, then that would be a numerical expression. Solution to an equation. Okay, let's use this one right here. Okay, that's an equation. A solution to an equation is when you have a value of x that makes this true. It's really that simple. As you'll see as we move into quadratic equations, sometimes there's more than one solution. So for example, if you have something like this, there are two solutions to this. X equals 3 and x equals minus 3. They both make that equation true. So any value of x that makes this equation true or this equation true is deemed to be a solution. So in this case, what would be the solution of that equation? We have 5x equals 7. X is not by itself, it has a neighbor. The neighbor is being multiplied by 5. We would divide by 5 in order to get rid of that neighbor. We immediately do the same thing to the opposite side. Not a similar thing, but the exact same thing. And this indeed would be our solution. Exponent. An exponent is simply a number. An exponent is the power to which a number or a variable is raised. All right, so that would be an exponent, the 3. Here, if you have 2 squared, oh, that's not a good example. If you have 3 squared, this would be the exponent. Okay, I think you guys know that. Next one. Like terms. Okay, a like term is when the variable and the exponent are exactly the same. Okay, let me write that down. The variable has to be the same, and 2, the exponent has to be the same. In order to have like terms, both these criteria must be met. Not one, not the other, both. So let's look at the ones listed here. What are our variables? Well, for now, we ignore the coefficients, by the way. They do not play a role in determining whether we have like terms. So let's ignore those, and let's focus on the variables. This variable is x. This variable is x. This variable is x. And this variable is y. So we know there are no other y variables. So this term right here does not have any like terms. All right, so we cannot combine this with any other term. So as I simplify this expression, I'm going to immediately bring that down because that is not going to change. Now, let's look at these other three candidates to see if they are like terms. Okay, we have an x squared, x to the first, and an x squared. So we do have like terms. These are our like terms right here. Now, what is the significance of like terms? What's the big deal? Why do we go into this discussion? Well, the answer is when you simplify an expression, the idea is to combine like terms. So let's do that. We know that this has no other like terms. There are no other x to the first power. So I'm going to bring this down as part of the final answer. Okay, let's take this away. Okay, so you already know that these two terms are going to be in the final answer as is. Now, let's look at these two terms. Let me erase this one. We are going to combine these. And the reason why we can is because the variables match and the exponents match. Both criteria are met. So how do we combine them? Well, we say to ourselves, we have 3 of something plus 4 of that exact same something. That is like saying, folks, that we have 3 apples plus 4 apples. What does that equal? 7 apples. So down here we are going to write 7x squared. Okay, so now we have 7 apples plus 2 oranges plus 1 kumquat, for example. You can put in anything you want here, but my point is these entities are different. These variables are the same, but their exponents are different, and this variable is totally different. Inverse operations. Folks, inverse operations undo one another. So when you have five plus 3, if you want to undo this addition, you use subtraction. And when you do that, plus 3 minus 3 becomes 0. This subtraction, for lack of a better word, undid or reversed this addition. That makes addition and subtraction inverse operations. They undo one another. I know that doesn't sound like a very sophisticated term. So when you're dealing with the inverse operations of addition and subtraction, the result is going to be 0. Now, multiplication and division undo one another. But here the result is going to be 1. Okay, let me give you an example. If you have 5 times x, that's multiplication. What undoes this operation is the opposite, which is division. Division and multiplication are inverse operations because these 5s cancel out and result in 1. Distributive property. Distribute. The word distribute means to apply to more than one person or thing. Okay? It means to influence to pass along your influence. So for example, if you're a teacher in a class and there's a lot of students, and you're a teacher over here, and you have a stack of papers in your hand, you're going to walk around and distribute the piece of paper to each of these students. Okay? You're going to influence each of these students. Okay, so what does distribute mean in the math context? Distribute in the math context specifically means when you have a constant out front and you have parentheses. So now the influence of this multiplication by 5 is going to be distributed to not one student in the class, but all the students in this class. It is just like a teacher passing out a piece of paper to each of these students. You can have more than two things, or more than two entities, more than two terms in a parentheses. You can have this. Here, again, the influence of this 5 would be passed to each of these terms. So this would be 5x plus 15 plus 5y plus 5z. Okay, while we're on this topic, so again, this is distributive property. So if you want to take a screenshot, I forgot to mention that at the outset of the video. I also recommend taking screenshots as you go to help you study. While we're on the distributive property, I want to talk about distributing and dealing with negatives. Okay. If you're presented with this problem and you're asked to perform the distribution process, you get your arrows popping. Okay. Three separate multiplication problems. In addition, I recommend you circle the integer and the sign that precedes it. The yellow arrow becomes 5 times x. The green arrow becomes 5 times negative 6. And the red arrow becomes 5 times negative y. I also think it's helpful that when you're multiplying by a negative, put the negative integer in parentheses down here as you do this second step. Notice I left the signs out. Okay, we'll get to that in a minute. This first yellow arrow is pretty straightforward. That's going to be 5x. Now, when you multiply 5 times negative 6, again, I think it's helpful to circle that. You get negative 30. Now the sign is listed. Here, with the red problem, same thing. 5 times negative y is going to be negative 5y. Sorry, I left that x out. So this will be your final answer. Okay, folks, in order to be successful at math, you have to be able to negotiate negative signs when you distribute. Next one. Associative property. Okay, when I hear the word associates, I think of 2 or more people that are together. Okay, I think about 2 students sitting together, they're associated. When I was a surgeon, I was associated with multiple other physicians. We were all associates in the same medical practice. We're together. So when you see the word associate, I want you to think about parentheses. Okay, when we look at this equation, we know that to be true. But what is also true is that you are allowed in this particular situation to associate with parentheses the B plus the C and the A plus the B, and you would get the same result. So when you see the word associate, think parentheses. Same thing is true with multiplication. You know that A times B times C equals A times B times C. But if they put parentheses in there in addition, they're talking about the associative property of multiplication. Okay, so parentheses, associates. Two students, associated. Multiple professionals, associates. Parentheses. Commutative property. When I see the word commutative, I think about commuting back and forth to work. That's what our parents do. So the commutative property states that you can switch the order of things when you're dealing with multiplication and addition. You commute both ways to work. You can switch the direction of the terms in this case or the factors in this case. Okay, let's do some problems. Okay, sorry for that delay. Okay, first problem. This problem asks us to solve for x. We talked about this in class. What does solve for x mean? Solve for x means we get x all by its lonesome. That has been solved for x. If you have this, that is not solved for x. Same here. In both of these situations, in white, x is not by itself. And the way you can test for that is in your mind, draw a circle around the side of the equation that contains the variable. If there's any other entity other than x, or a hidden 1, okay, because technically there's a 1 here, then it is not solved for x. Okay. Let me pose this question to you. Suppose, folks, you had negative x equals 12. Have you solved for x here? Answer is no. Look at the difference between up top and look at the difference between this yellow situation and this red. That negative sign is the same thing as saying negative 1 times x. That is not solved for x. So in this case, you would have to divide both sides by negative 1. Now x is isolated. And 12 over negative 1 would become negative 12. Okay, remember, when you have a positive and a negative and you are dividing, your end result is negative. Okay, so as we move through these problems and you see the term solve for x, immediately you have to get x by itself. Okay, so now we know what it means to solve for x. Let's talk about how to do it. Okay. The first thing you notice is x is not by itself. The second thing you ask yourself is, what is the operation being performed between x and any of its neighbors? So here there's only one neighbor, 6. Division is going on. That's what fractions are. They're division problems. So that's division. So immediately we know we have to employ the inverse operation, which is multiplication. How do we do that? We multiply by the neighbor. The second we do that on the right side of the equation, we have to do that to the opposite side. And here's why. When we started out at the beginning of this problem, we had two sides of an equation, a left side and a right side. I'm going to take away this multiply by 6 for a second and talk about what would happen if we didn't multiply the other side by 6. Okay, so we come along here on the left side, and in our pursuit of getting x by itself, we multiply by 6. To make it a little bit more clear, let's say 6 over 1. When we do that, these 6's neutralize. 6 over 6 is 1. However, and that's our goal, we did that on purpose. However, folks, when we come along and we multiply that left side by 6, this equal sign that was present at the beginning, where the left side equaled the right side, is no longer valid. We have changed the left side. Once we change the left side, this equal sign no longer applies. So I'm going to take it away, because these are not equal. This and this, left side and right side, are right now not equal. When I bring the equal sign back, I have to multiply by 6 on the other side. So I think it's nice to say out loud the dictum, whatever you do to one side, you do to the other. But if someone comes up to you and asks you, why do you do that? Why do you do to the opposite side what you did to the first side? There's your answer. To maintain the integrity of that equal sign. Okay. Let's start over. We do that, excuse me, when you multiply when you multiply 78 times 6, you get 468. Okay, let's move on. Here we have an inequality. We're going to follow the same rules, but we have to be cognizant of one thing, and that is, if we end up multiplying or dividing by a negative number in our pursuit to isolate x, we have to flip the direction of that sign. So let's talk about that. This particular problem, you recognize that x is not by itself. What is the operation being done between x and the neighbor? division. How do we undo it? With the inverse operation. The second we do that to that side, we do it to the other side. These cancel out, and we get x is greater than 60. Okay, you'll see another example later on in this video where during the process of solving for x, we had to either multiply or divide by a negative number, and when we do that, we flip the direction of that sign. Okay, here we go. Our first proportion problem. Let's talk about this. Kennel has 35 dogs. Some are puppies. Some are adults. Dogs can be either a puppy or an adult. It is the same thing, folks, as saying we have 35 students. It's the same thing as saying we have 35 students. Some are girls. Some are boys. Whenever you get this situation where this first entity can be described by two different subsequent entities, two divisions of this category, you're going to get a problem like this in math for the rest of your career. So if you learn to master this now, you will do swimmingly on these problems. Okay, so let's talk about how to analyze these. The ratio of puppies to adult dogs is 1 to 4. So you're going to have 1 puppy for every 4 adults. Again, anytime you see a ratio like this, 1:4, you can rewrite that as 1 divided by 4. Okay, now, if this is the ratio, how many puppies are there currently? Okay, so what do we know? We know that right now there are 35 total dogs. The successful solving of this problem is predicated on you recognizing something very important. The fact that 1 puppy for every 4 adults also means that you have 1 puppy for every 5 dogs. All I did was add the puppy and the dogs to get 5 dogs. So in this circumstance, when you have 5 total dogs like you have here, one of them is going to be a puppy. You also know that if you have 5 dogs, like this, you have 5 dogs, 4 of them are going to be adults. Once you make this connection, once you recognize that there is more information than initially meets the eye when you are told there's 1 puppy and 4 adults, and you extrapolate it to this and this, you can solve anything they ask you. Okay, so let's do that. These are what I call weapons. You are now armed with weapons to solve anything they throw at you. Okay. So here's what they want. 35 total dogs. How many puppies? You see this word how many? Whatever follows words like how many, how much, whatever variable follows it, that's what you set to x. Okay? You're going to see problems. How much does something cost? How much did the total meal cost? How much? Whatever follows is x. How many? Whatever follows, that's your x value. Okay, now, if you're trying to figure out how many puppies for 35 total, which one of these are you going to use? The answer is this one. This is the weapon you're going to use to solve this. Why? Because it has everything in it that this proportion does. Puppies to total, puppies to total. So how do we solve this? We cross multiply. Or you can use the arrow technique, but I want you to get in the habit of cross multiplying. I think it's a better way to go. So if we cross multiply, we would get 35 times 1 equals 5x. We would divide both sides by 5, and we get x equals 7. That's how you do these problems. If you didn't follow that, I encourage you to rewind it and look at it again. That is the beauty of video. Okay, we'll do this problem and then we will end part 1 here. Okay, Ava and John share this reward in this ratio. Okay, so we have Ava with $2 when John has $3. How much money does Ava receive? See that those words, how much? Whatever follows, that's what we set equal to x. So immediately I'm going to put here x dollars Ava. That's what we're going to try to solve. Again, indicated by words like that. Okay. And the total reward is 40. Again, you have to be able to look at this and extrapolate more information that meets the eye. So in addition to telling you that for every $2 Ava receives, John receives $3, this statement is also telling you that if the total is $5, okay, got that by just adding these, then Ava's going to get 2 of those $5. And John, when the total is $5, is going to get 3 of those dollars. Now, which of these weapons, these 3, are we going to use to solve this? We're going to look for one with Ava in the numerator and total in the denominator. Well, out of the 3 weapons, this is the one that fits. So we're going to bring that up and use that to solve this problem. Set them equal, and we're now going to cross multiply. Okay, once you have your proportions set up, Ava dollars, Ava dollars, total dollars, total dollars, then you can ignore everything else and just do the math. So sometimes I will come down here and just do this. 2 over 5 equals x over 40. Will we cross multiply? 5x equals 80. 5x equals 80, and x is going to be 16. So Ava's going to get $16 out of the 40.